So in 5.1, we learned how to solve systems of equations by graphing. Well, now we're going to solve systems of equations by substitution. So you see on this page here, I do have a graph. Well, that's because we're going to take this system of equations, these two lines, and we're going to graph them just like we did and find out what the answer is. So as you can see, I'm graphing the first line. We should be very adept and quick at graphing lines by now. So this is the line y equals x minus 3. All right, I'm going to change my pen color over here and just graph the next line. All right, so I have to solve that for y. Y equals negative 2x plus 9. All right, so I'm going to start here at 9, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and look where we cross. We found out that our answer was 4, 1. Now I did that on purpose because I want to show you that we are now going to learn how to solve this by substitution, and we will get the same answer. So you may be asking, what is substitution? Whoops, I don't want that. Substitution is a way to solve this when there is no graph. We just want to quickly do it, no need to graph it, but we do want to find if these linear equations cross. So here are our steps. I'd advise you to write these down and follow them step by step when you're in class working on your homework tomorrow. Pick either equation. It doesn't matter. When I pick an equation, I generally like to pick the easier looking one. And that's going to all be opinion to you, but to me, this is the easier looking equation. Why? Because the variables don't have coefficients. Solve this equation that I picked for my favorite variable. Well, in this equation, I have two variables, y and x, and it just so happens it's already solved for y, so I don't have to do anything to it. Take the equation from step 2 and substitute it into the other equation. So this is what it's saying. Every time I see a y, I may replace it with x minus 3. So I'm putting x minus 3 into the other equation every time I see y. So if I rewrite that first equation, it's 2x plus, and then every time I see a y, I'm replacing it with x minus 3. There, I substituted. I solve for the lone variable that's left, that being my x. And hopefully, whoops, it's not 3x equals 9. Let's get an eraser out there. It's 3x equals 12 because I bring that negative 3 over. And then when I divide by 3, I find out that x is 4. Hey, what do you know? But now, I'm not done. Because remember, if linear equations cross, then it's at a point. So I need to go back and find my second variable. In this case, I need to find my y. But look how easy it is. Y is, see right here what they told me to do? To get my y variable, all I do is subtract 3 from my x variable. Oh, my x variable is 4. 4 minus 3, so my y is 1. Now the last thing you should always do is check to make sure your answers work in both equations. So let's clean these up a little bit here so I can see what my equations are. And it says, for the first equation, that if I double, if I double my x value and add y, I should get 9. All right, double my x value, add 1, I should get 9. Yep. And then we already know that this is right because this is how I got my y variable. My y variable is obtained from taking my x variable and subtracting 3. Awesome. It works. And here's another one to solve. And this one's a little trickier. Look at all these coefficients I have right here. And I did that on purpose to show you that it's not that hard. We just have to be very careful. Pick either equation. Which equation am I going to pick? I'm going to go with the second one because 2, 10, and 26 all can get divided by 2 if I choose to solve for this y. Now you may be looking at me going, why? I wouldn't know to do that. But it doesn't matter who you solve for. Any one would work. So I'm going to solve this equation for y. All right, got it solved for y. Take the equation from step 2 and substitute it into the other equation. So this equation is going to be every time I see a y, I'm going to replace it with 13 minus 5x. So I start rewriting the first equation, but as soon as I get to this y, it gets replaced with 13 minus 5x. Hopefully this part of solving won't take you that long, but be careful here. A negative times a negative is a positive. It's the little things that often make this difficult, not the concept itself. Keep simplifying. 4x and 10x is 14x. I'm going to move the 26 to the other side. Resulting in 42. So x is 3. But remember, it's a linear equation, so I need a point. I need to find out what my y variable is. Well, right here, I told myself an easy way to get the y variable. The y variable is 13 minus 5x. All I did was rewrite this one into much easier terms. All right, so that's what I'm going to do. 13 minus 5 times 3. So my y should be negative 2. So I think my answer is that these two lines cross at the point 3, negative 2. Well, let's check myself. Check myself before I wreck myself. All right, anyway, 4 times 3 minus 2 times negative 2 should get me 16. I'm checking this first equation here. 12 plus 4, because negative times negative is positive. Does that equal 16? Beautiful. Let's check my second problem. Double the y variable, 2 times negative 2. Add on 10 times 3, and it should get me 26. And it does. 26 gets me 26. All right, now I have it, but I don't have my steps over here. But you can follow along. Pick my easiest one to solve for. Well, 3, 2, 8 don't go into each other. 4, 16, 6 don't go into each other. So which one do you want to solve for? I'm going to go for this one up here. I don't know why. They're smaller numbers. So I'm going to solve that one for y. 2y equals 8 minus 3x. Divide by 2. Y equals 4 minus 3/2 x. Okay, so every time I see a y, I am going to replace it with 4 minus 3/2 x. So since I started with the first one, my substitution is going to occur into the second one. 4, instead of that y, I write 4 minus 3/2 x minus 16 equals negative 6x. All right, got a lot of solving to do here. 4 times 4 is 16. 4 times 3/2. Please do not shudder at this. There's a lot of ways to do it. 4 times 3 is 12, divided by 2 is 6x. 4 times 1.5 means 4 times 1 plus half of 4, which is 2, so you get 6. A lot of different ways to do it. All right, now I'm going to solve. Oh, I can clean up over here. 16 and a negative 16 cancel out. I have negative 6x equals negative 6x? Well, if I divide both sides by negative 6, I get x equals x? Yeah, you just got a true statement. Ooh, what is this? Remember those lines we talked about in 5.1, that lines can be either parallel, skew, on top, or cross once? Well, guess what you just found out here? You have two lines that are on top of each other. So that means every combination of points on the line are the answers. Because really, these were the same lines. See, this first one, when we solved it for y, it's y equals 4 minus 3/2 x. Well, I'm going to solve the next one for y also. Let me get a different color pen so it stands out. I'm going to solve this one for y. 4y equals negative 6x. I'm going to bring that 16 over as positive 16. Divide by 4. Y equals negative 6/4 x plus 4. And hey, does it negative 6/4? Goes down into negative 3/2. So look, these were the same lines. Y equals a plus 4, a plus 4, a negative 3/2 x, a negative 3/2 x. So if I were to graph these, I'm starting at 4, I'm going down 3 over 2, down 3 over 2, down 3 over 2. And if I graph the other line, I'm starting at 4, going down 3 over 2, down 3 over 2. So every combination, this is a true statement, these lines are on top of each other. All right, last one we're going to look at. I'm going to solve this one for y. Bring that 3 over. I'm going to multiply by 2 to get rid of that, which means I'm going to multiply everybody here by 2. Now I can substitute. Every time I see a y, I'm going to substitute in 8x minus 6. And solve away. Add that 12 to the other side. Bring this 16x over here. What? Wait a second. I'm getting another weird one. This time, I'm getting 0 equals 15? That's a false statement. So guess what with these lines? There is no answer. Because if I were to graph these, give me a second here. If I pull out my grid and graph them. Okay, if I were to graph this line, I solve for y, and it tells me to start at -6 and then go up 8 over 1. Up 8 over 1. That's my line. Let me change my pen now. Pick a nice pink one. And we are going to solve this second equation for y so we can graph it. Divide by 2, y equals 8x plus 3/2. So when I start at 3/2, which is 1.5 right there, and then I go up 8, which would bring me up to 9.5 over 1. If you notice, these lines are going to be parallel. They're starting at different spots. It's not a very good line I drew there, but since they have the same speed, one line is not going to catch the other. They're going to be parallel. Different starting points, same speed, same slope. So we have those two new ones we talked about yesterday are showing up now. If you solve and you have a false statement, there is no answer. If you solve and you have a true statement, then the lines are on top of each other. They're the same line. If you solve and you get an answer as x equals a number or y equals a number, then they cross at only one point. See you tomorrow.